Hailey Marcello, and I'll be teaching you how to build an electric train state machine using both Quartus and ModelSim. To get the outcome, you must understand the design. There are two trains, A and B. Each of them goes around the tracks shown from left to right. These trains signify the outputs of the problem. When the train goes over a specific sensor, it then moves the train. These sensors signify the inputs. This shows how each train moves throughout the track. The inputs allow the train to move in a certain way. The outputs that are visible show how the train moves. If there is no output there, then it did not move. When a specific input is 1, the trains will move along the track to a different state. Now that you understand the design, let's build it. Open up Quartus and select New Project Wizard. Put the file somewhere where you know where it will be. I like putting all my files in the same document. Make a new folder. I'm going to name it State Train. State with a T. Make sure you name the project that same name. Go to the File tab in the far left and select New. Then open up this state machine file. I personally like to use State Machine Wizard, but you can also do other ways, such as get the state machine bubbles. We want to create a new state machine's design, so you press OK, and then a pop-up appears. You want to leave the General tab the same. As for the inputs, you need to make them the sensors. So I'll be putting S1 through S5. The next tab is the Outputs tab. The Outputs tab represents the switches and the trains. The trains are seen as DA0 and DB0, whereas the switches are just seen as SW1 and SW2. The states are what each part of the train are in. They start at about, AB out, technically speaking, and go in succession. But it must start with about because that resets the entire thing. The transitions are what's most important. Whenever an input is activated, it must be typed as that sensor. For example, when going from about to about, and S2 are 0, which is signified by a tilde. Also, when there are two inputs being shown, you must use the ampersand symbol that is used is used to represent that both inputs are being used to get from state to state. You replicate what was seen earlier on the table on the state machine wizard. Make sure to count the 13 states, transitions from state to state, because that's how many there are in the diagram. So I'm going to count right now. The last tab is the Actions tab. The Actions tab tells us what the outputs will look like in a specific state. So, for example, when train A is at state A bout, it will have a value of 1. So will train B, and so on and so forth. Again, this all represents the state machine diagram that was shown in the beginning. Make sure that there are 10 output ports for each state and that they are in the correct output value. You click Apply and can exit out. The state bubbles and their movements are shown here. Once you have completed your state machine wizard and it is all correct and that you saved it, you can generate a Vhdl file on the box next to the state machine wizard. Click on it and you click Vhdl, which is what you want. Since it is correct, a Vhdl file will appear. You want to save it by clicking Control S and then going to Model Sim. When you go to Model Sim, click on the far left and under File, New Project. Once here, you want to choose the same location that all of your other files were in, which in my case was under the desktop, under here, and under train state. You want to click that folder, click OK, and name it the same, or at least relatively similar. A new pop-up will appear. You want to click Add Existing File, and the file that you want to choose when you click Browse is this Vhdl file, which in my case, it doesn't show up correctly right away, so I have to go under File Type and click Vhdl Files. Click Open. Once it appears, you'll click X, and then click here, and then go to Compile All. Once the check is here, you then can simulate it and click Run Start Simulation. Then this pop-up appears. You want to go to the Work File Library, click the plus, and then click the entity of your file. Once this process appears, a lot of pop-ups will appear. You want to have the objects come up, and if it does not come up, you go into View, and then you click the check for objects. Once there, you hit Control A for all of your inputs for the last one. Once you have all of your components, you want to right-click and then click Add Wave. The wave will appear here. When you have all the inputs on your waveform, the first thing you need to do is change your clock to have a synchronous waveform, and you do that by pressing falling. You can make your reset 1 to start off your simulation at a 0. When run, it starts with about. Set reset back to 0 when you change from states. Now, to go from state about to be in, you want to force S1 as a 1 and keep S1 as a 0, as stated earlier. It moves from about to be in, and so do the outputs. When moving from be in to a stop, that change S1, is the only one that changes. You right-click it, click force, and make it a 1. And then it changes. A stop then goes to A in when S3 is a 1. And from there, it goes to B in when S1, S2 is a 1, and S4 is a 0, which is what the state it already is in. But to show you that it doesn't matter if it changes, let's make S3 a 0. It will change anyway. From B stop, it'll go back to B in once S4, only S4 is a 1. B in can also return to a stop when S2 and S4 have a values of 0. S1 stays high when it goes to a stop. Basically, when all of them are 0, it will go repeat that state. But yeah, it shows the entirety of this, and I completed this project to its complicity.